is a monster, okay? And new discovery. Core Assets today. Now, this is a company that I talked about, British Columbia focused. They are looking at a project that's north of the Golden Triangle and in a country that a lot of people might scratch their head and say there is absolutely no way you could find a deposit of this type, but they have, and they found it by boots on the ground exploration over the course of a few months last summer. They went up to their property with the intention of doing stream sediment sampling. And as they started walking around, basically because the snow melted away from some areas, they started to find outcropping mineralization. So, heck with stream sediment sampling, when you got rocks sticking out of the ground, why not focus on that? So this is a really exciting story. It's one of these classic stories of receding snow line and new discovery. Let's go to the next slide. Company is fairly tightly structured right now. It's got about 58 million shares. We are doing a placement into the company that will close in a few days. With warrants and options, you can see they're fully dilute, about 77 million shares out. Management and directors, 36%. And I'll tell you, this young guy, this Nick Rodway, who is the prospector who came to me last year, very sharp individual. He's a young guy. I've said this many times, I like to champion the next generation of prospectors and miners. And I think this guy's going to have a great career. And he's actually done a very good job of positioning himself in this story. So he is fully vested. He's basically parked most of his wealth into his company. I consider that a very, very good sign. Good future for the company. Let's go to the next slide. Okay, so I told you where the location is. This is way up in northern British Columbia. It's kind of southwest from Matlin, and yes, this will require flying in and operating this drill program or any drill program using a helicopter, but you do have road access into here, and you have some infrastructure. You had a village as well as various sites you can set up a camp, and the company can operate this. I'm very confident. Now it is up into snowy country, so this is not, it's higher elevation. It is not for the faint of heart. That is one thing everybody who invests in this has got to be aware of. This is rugged terrain, and they're exploring areas that have literally just been exposed through melting of the snow line, the glaciers, and so forth. So, do I think this is a problem? You know what? If you're looking for a big target like I'm about to tell you about, I don't think it is. If we were talking a little, potato target kind of thing, no way. But this one is a big story, and I think in this jurisdiction, I think you can advance it. Let's go to the next slide. What are we looking at? We are looking at basically a giant porphyry manto type system. Okay, the red in this image, especially in the upper part, those are sulfide bodies that have replaced limestone, shown in blue. Limestone likes to react with fluids that come out of porphyries, and often the product of that is sulfide deposits. So basically, just massive sulfide minerals, just all together, like 90+% sulfide, and they take the form of mantos, which are basically blanket-like deposits that replace beds, or chimneys, which are bodies that cut across the beds. All right, so that's the kind of setting we're talking about. But there is also that porphyry down at depth. There's certainly a porphyry driving this system. There's almost no question. You also get things like skarns right around the porphyry. Skarns are where the intrusive rock itself, the magma, interacts with those limestones and other rocks, and it just totally cooks them. It makes them into completely new, minerals and whatnot. And the skarns can also be important hosts to the metal deposits. But we're going to talk mainly about these chimneys and mantos here. Let's go to the next slide. I'm going to go through a number of examples here. These are in the corporate presentation. This Nika deposit in Chihuahua. This is a major, I think about a 45 million ton carbonate replacement deposit in Chihuahua. It's basically a world-class mine. And you can see here that the deposit, it looks literally like a system of caverns that have been filled in by sulfides. You can see the red wormy tubes and whatnot. That's what these deposits look like underground. Okay. And oftentimes where they stick their nose up, there's not a lot of surface expression. In fact, in this case, the existing mine, this huge 45 million ton deposit, was found by chasing that small artisanal level working there that's only about 75 meters long down into the ground. And lo and behold, look at what's underneath there. Just absolutely amazing. I like to watch these videos on YouTube where the guys pour molten aluminum into ant hills, and then they let it cool down, and then they dig up the um, the aluminum tubes and whatnot that replace the ant colony, and they can be amazing. I mean, that's the way one should think about these. They can be very, very extensive, just like a cave system in the ground. Let's go to the next slide. Okay, here you can see Santa Eulalia. Eulalia, this is again in Mexico. About 30 or 40 million tons, big deposit, world class. And again, you can see that it is just a complex network of mantos and chimneys, cross-cutting things that replace the limestone here. And to get a sense of scale, that's 4 kilometers from end to end. Once again, this deposit was found where it just barely poked its nose up. Look at there, a 40-meter wide area of sulfide that barely poked its nose up out of the limestone and led to the discovery of a world-class deposit. Let's go to the next slide. Taylor Deposit. This is in southern Arizona. This was actually sold by Arizona Mining a few years back to S32, and it's currently under development. It is about 150 million ton sulfide deposit, a carbonate replacement deposit. And you get a sense of the scale. In this particular image, we're looking at a field of view of maybe 1.5 kilometers across. Okay, and this thing is absolutely massive. You can see how some of the bodies replace the beds, some kind of go down and then connect to other beds at depth. This is an extensive system that is absolutely hands down world class. 150 million tons currently under development. Wow, wouldn't it be cool to find something like this? Notice you don't see much at surface in this image. Most of this deposit is below ground. Let's go to the next slide. So what have Nick and his team found? As the snow has melted, like I said, it has left exposures of mantos and chimneys literally sticking out of the ground. So when they went over the top of this ridge, they got into this area, they find this grizzly showing manto. It's basically a continuous body of sulfide, several meters, like 5 meters plus thick, that extends for at least 350 meters on strike. I, in my career, have never had the pleasure of finding something so bold and brash as this. I mean, this is just remarkable. They did sample it. We'll talk about the values here in a minute. They also found chimneys, bodies of sulfide that are cross-cutting the carbonate section here. Nobody in their dream would have thought there would be carbonate replacement deposits in this country. Now, so, some geologists have recognized there are carbonates, massive carbonates up here, but for the most part, to the south in the Golden Triangle, you do not have these kind of reactive host rocks, but you do here. And lo and behold, it looks like there must be a very large porphyry underneath this mountainside that's driving a carbonate replacement system. And it's just a delight to see a discovery like this made by truly just walking over the top of a ridge and starting to take samples. Let's go to the next slide. Here are some of the images of sulfide. Yes, the rock is often dark brown or dark red because the sulfides oxidize. They turn rusty, okay? And, as they weather, water comes in contact. But notice the rock outcrops are all polished. Why are they polished? Because this area was just glaciated, okay? I mean, it's basically just, brand spanking new. It's the snow has melted back and it's exposed these fresh outcrops of sulfide. Wow. I mean, this is a dream. Like this would be like walking over the hill and finding, in my view, an entire mineralized district. An entire CRD system, completely preserved, and also just sticking out of the ground. Now, the guys have done a lot of channel sampling. The assays for the channel samples should be coming back in the next few weeks. Okay, so they do have assays from spot rock chips, but they also have a lot of data coming back for using saws going across these bodies of sulfide and carefully chip channeling the sulfides. And those numbers should be very exciting. Let's go to the next slide. Okay, here's a comparison of their discovery, this brand new Grizzly Manto discovery, as well as some of the chimneys in the more in the foreground. It's compared to the Taylor deposit. Notice the strike length of the Grizzly is about 375 meters. Look over there at the Taylor cross section. That's about 400 meters. So, in terms of sense of scale, thickness, everything, this tick, tick, tick. It all matches what one would expect in a classic world-class carbonate replacement system. All right, this is wonderful. But let's talk about grade. Let's go to the next slide. All right, these two maps show on the left-hand side zinc grades. Now, it's kind of hard to see the dots. I would encourage people to go to the company's presentation. You can look at this over the weekend or something. The dots you see in the zinc, there's a lot of red ones. Obviously, those are higher grade. I'll show you a table here in a minute that will help evaluate the meaning of these assays. Okay, but on the right-hand side, you have silver. Again, look at the scale and the silver values. We're talking up to over 2 kilos of silver per ton in some of these samples. All right, so now next thing to notice, scale. Okay, they found samples way off on the northwest side of the glacier there that are very similar to what they find on the southeast side. And that's 6 kilometers across. Okay. So basically, we're dealing with a carbonate replacement system, 6 kilometers of footprint. That is huge. All right, let's go to the next slide. Assays. Let's look at these numbers. This is remarkable. I've never in my life taken first pass sample suite like this. Okay, you're seeing many silver numbers in the hundreds, many hundreds, even thousands. You got one silver up there at the top, a little over 2 kilograms per ton. These are unreal numbers for a first pass program, just marching around chip channel sampling various sulfide bodies that are sticking out of the ground. Now they have to do their saw channel samples here, or they have to get their assays back, and we'll see a little bit more. But I'm very impressed with these numbers. Now the copper is elevated, 0.x% in much of this, but occasionally, especially down there towards the bottom, you're seeing multi-percent type stuff. That is very encouraging because that copper is probably pointing you towards where the porphyry center is. The lead and the zinc are also very high. You're seeing many numbers above 10% lead, many numbers above 10% zinc, even the values that are in the percentages, multi-percentages. Those are great numbers. Okay, this is an amazing data set. There is a bit of gold. Notice some of the numbers, mainly towards the bottom there, are in the multi-gram gold range too. Let's go to the next slide. Now, I showed some images when I was talking about Western Alaska copper and gold a few weeks ago. And I like to put these plots up again because this is a very similar story. It's basically a carbonate replacement system. And we have a lot of data on these. These are basically plots to show the cumulative frequency of the deposits and grade of lead, zinc, and silver. And what does this mean? Well, I put a red circle around the values that you saw in that previous table, where that would plot on each one of these. And basically, for each of lead, zinc, and silver, the values that they're finding in these chip samples that they took in the field are in the upper 10 15% of all deposits of this type. Okay, that's very encouraging. I follow the grade. That's what you need to do. And this one is definitely showing its high grade. It's in that world-class realm, possibly. Let's go to the next slide. How about size? Well, my best bet is they're going to find a system here. Given this footprint of this thing is over 6 kilometers across, I think they're going to have a system here that's going to be in the tens of millions of tons. I truly think it is analogous to those examples we talked about earlier. Who knows? Maybe it gets north of 100 million tons. If it does fall within that red circle, wow, this could be an absolutely amazing discovery. Again, you work in country like this, you want to go long, you want to find something big, and this system, given the size that we see right now, I think will deliver. That's our bet. That's why we've invested in. Let's go to the next slide. Okay, they put this image into their corporate deck. Basically shows you the red dots of where samples of lead, zinc, silver, these high grade samples come from. And they've kind of schematically drawn, how the system might be interconnected, like how the fluids move. The belief here is that the porphyry is that magnetic anomaly, that kind of bright pink thing, in what they call the potential porphyry hub. I tend to agree. I think that, looking at copper values, that's where most of the higher copper is. I would say that there is a porphyry buried at depth. Whether it's shallow enough to hit with a drill, don't know. But nonetheless, just this carbonate replacement target on its own, 6.6 kilometers from northwest to southeast, and almost 2 kilometers from southwest to northeast. I mean, this is a monster. Okay, and over here on the right, a map showing the Bingham Canyon porphyry system with its surrounding carbonate replacement deposits and skarn deposits at the same scale. Okay, you can fit a Bingham Canyon into this picture very easily. That's impressive. We went long. We love this story. Let's go to the next slide. Okay, they do have another project. It's to the northeast. Lavardiere Historic Drilling. This is a copper skarn. It's too far away to be directly linked to this silver lime area. There's no way these are the same system, but this is showing there's another likely porphyry center that is generating high grade copper values in this case skarn host rock. All right, don't know so much about this. Actually, they kind of got sidetracked from doing more work here and actually spent most of their time on the new discovery, but this is yet another target on their property.